Hey there, in this video I'm going to configure the tunnels on router 11 and 12. I've just configured auto mesh tunnels on 15 and 16, and now I also need to configure manual tunnels, this time from 11 to all these other PEs, and the same from 12 to these other PEs, because in the end we'll need to push traffic between all these CEs and we'll need LSPs to do that. And we do have some requirements for these tunnels. First one is to load balance the traffic, and what I actually had in mind for this was to have two tunnels from, let's say, 11 to 12. First tunnel should take this path and the second tunnel should take this path, and same from router 12 to 11. And let's just get started. So first is the IPv4 unnumbered MPLS traffic engineering loopback 1. We'll use loopback 1 as the source for these tunnels. And in order to achieve this load balancing, we're going to need two explicit paths and two tunnels. So let's just go ahead and configure these explicit paths. So the first one, I'll use numbers for these. The first one will be ID1. And it's index 10. We're going to use addresses for that. And next address, I'm going to use, let's say, a loose next address, and I'm going to put here router 13 here. And the second explicit path will have router 14 as a loose next hop. So explicit identifier 2, index 20, next address, index 10. Next address, loose IPv4 unicast 14.14.1. Okay, I have the explicit paths done, and now let's just start configuring the TE tunnel. So first one will be int TE tunnel 1. So you have this shortcut with XRs. Instead of doing tunnel TE1, you can also do TT1, and it's easier, of course. And we need to load balance. So first, let's configure the path option. It's path option 1, explicit identifier, let's say 1. Then we need to set a metric of 10, and this metric is actually put under the auto route announce part, and we'll put here a metric of 10. And we also need to signal to make a 100 megabits per second reservation for CT0. So signaled bandwidth 100, 1, 2, 3, because this is 100 kilobits and I actually need to reserve 100 megabits. And we also need to put the class type, and this time is going to be class type 0. And don't forget, we also need to modify the priority of this tunnel. So priority 0, signaled, not signaled, but priority 0 and 0, because of those remappings that we've done. And of course, we're also going to put the destination, and this destination 12, 12, 12, 12, 1. And this is how these tunnels will look like. Let me make the second tunnel towards router 12. So it's, I don't need to put the config part yet, so it's tunnel TE2, and it's just going to use a different explicit path. Okay, and we also need to configure two tunnels towards 15 and 16, so it's TE3, 15, 15, 15.1. Hopefully I don't forget anything about this dynamic part. Okay, and then 16, 16, 16, that one. And let's see the whole configuration. Explicit paths, source, and 3, 4 tunnels, 1 and 1, 2 and 2, both to 12, and 3 to 15, and 4 to 16. Okay. That should make it. And I'll commit this and apply something similar on router 12. And I'm thinking if I need to modify something, and yes, it's the destination of these 2 tunnels. And that's it. Okay, we have our tunnels and they're up. Show impedance graphic tunnels detail. And if I do a trace route to okay, we're using this tunnel. From this output, I understand that it's actually I'm using for these 4 tunnels, these 4 labels. So I won't see this label because I can't load balance the traffic because I don't have more loopbacks on router 11. But then when I'll do a trace route to 15, 15, 15, 1, I'll see this label being used. Detail. Yes, I don't know why I typed that. This is what I actually wanted to see. Label 24,012 and something similar for 16, 24,016. And this should be similar on this here, showing pellet traffic engineering tunnels brief. And we're going to see 4 different labels, and that's good. And what I'm actually interested in checking is that we're using different paths for these 2 tunnels. Show MPLS traffic engineering. Let me think. Tunnel 2 detail. So we see the arrow is going through 14, and that's good. That's for the first tunnel, and the second tunnel. The first tunnel should go through 13, and it's going through 13. So yeah, through 13 here. Okay. So I think we're good. Actually, we're not good because I'm not checking the correct tunnel. Let's see, I can show MPLS traffic engineering tunnels, and it's tunnel number 1. And let's also check the destination. So it's from 2 to 1, okay. And first hop is 13, and it's this one through 13, okay. And then tunnel 2 is to router 11, and it goes through 14. So we're good. We have 2 tunnels. First one takes this path, the second one takes this path, and that's what we wanted, to load balance the traffic between these 2 routers. And I think that's mostly it. Let me briefly go through these tasks. So it was for MPLS, the metric. Okay. we see here that they do have a metric of 10. It's the metric of the tunnel plus the metric that the router is advertising for the prefix itself. So show size database. (11.11.11). Where is it? Okay, here. So router 11 advertises a metric of 10 for this 11.11.11.1, and we're taking that metric and add the 10 metric of the tunnel, and this is how we got the 20. You remember we've enabled tunnels with the metric of 10. And we're done with everything. And the next part, we're going to start configuring BGP and PE to C routing protocols, but now at least we're done with this part of the configuration. And by the way, maybe you're asking yourselves why I'm not using this traceroute MPLS traffic engineering command. It's really useful, don't doubt that, but if you see I don't have MPLS OAM enabled. Actually, let me do that even if it's outside of the scope, and see how you can actually trace a particular, use traceroute for a particular tunnel. So it's traceroute MPLS, traffic engineering, tunnel TE, and let's just give it the number, and let's put 3 or actually 4 towards router 16. And we see that we're imposing label 16, and you no longer need to doubt. It's the easiest way to check what labels we're imposing for the tunnels, and I can't remember now, but forwarding, there was a way, yeah, to see it also here, of course. You can see that for this TE tunnel 4, you're imposing this label, so don't get confused. This is the binding label. I know if you've ever heard of it, it makes more sense. I've actually never seen this being used with RSVP-TE tunnels, but it's being used with segment routing. So this is the actual label that you're imposing when you're sending traffic for this TE tunnel 4. And again, we're done with it. I'm just closing. Thanks for watching. See you in the next video where we're starting with the BGP configuration.